Okay, hi, we're going to talk about the sine inverse circular function and talk about basically break it down into where it exists, why it exists, and all of those certain things. So what I have drawn up here is I've got the regular y equals sine of x function, which you all should have, hopefully, before you got into this chapter, would have graphed it by now. So what we're going to take a look at is the inverse of it and what happens and why certain things occur to it and what it is that we do. So if we take a look at this, we call the regular sine function here, we call it a function, and that's based off of something called the vertical line test. And the vertical line test is basically saying that if I drew a vertical line, okay, through any part of my graph, it doesn't matter how many times I do it, it will only intercept that graph one time, because for something to be a function, for every x input that you have, it will have one specific output. So, inverse. So if I think about inverses basically means take my input, make it now the output, and make my output now the input. So what I've done is that I've transformed this graph here. And when I take a look at this, okay, and I inverse, and if I inverse the entire function, and I come over here, and I draw it down here, and basically all I've done is I've switched the axis, because that's what it means to reverse the input and the output. I'm just calling one the other. So now what I have is this vertical axis is now, down here it was my input, but now it's going to be my output axis here. So when I take a look at this, some problems occur. Because if I take the inverse of this entire trigonometric function, you find that this no longer is a function. It doesn't exist. So issues arrive now. So what we can talk about here is that we can talk about an inverse existing on a very limited interval. So if we stop the intervals of which the function exists, we can then say, okay, on that very limited interval, the inverse would exist. But outside of that interval, it doesn't exist. And what you see here is if I take a look at this, okay, and we base it all around 0, which is, one of the most important numbers in mathematics here. If I base it all around the origin here, what I find here is that the inverse does exist, but it only exists on a very small interval. And since it's based around 0, if I chop it off at negative pi over 2, and I chop it off at pi over 2, and I were then to say, okay, well, let's conduct this vertical line test, you'll find that it will pass. So on this very limited scale here, what I've got now is I draw in the vertical line test, and you'll find that, yes, okay, well, on that limited scale, it is a function. So when we talk about the inverse of the sine, we can only ever talk about the inverse of the sine existing in either quadrant 1 or in quadrant 2. So now this is important because it's going to play a role later in my explanation here. So what I've got coming up here is that what I need to know is that the domain based off of this, that the domain of my inverse function can only ever be from negative pi over 2 being less than or equal to x, which is less than or equal to pi over 2. Okay, so what that means is that, my y value, or my x value, whatever it is that I'm going to have here, can only ever exist between negative pi over 2 and pi over 2. And what that simply means is that from negative 90 degrees to 90 degrees, that's where my outputs will have to occur, and that plays into the ratio functions, and we'll talk about that later. So here we go. First things first, the circular function. Here's the regular function. Well, if I were to take the inverse, okay, if I were to take the inverse of the regular function, what you have here is that if I take the inverse of sine, so if I take the inverse of sine here, I get sine inverse of y. And what that does is that basically this is the inverse function, so it gets rid of the actual sine function, just gives me the angle. And what we're left down here is the inverse sine, which is called the arc sine, okay, is what is written. Well, so essentially what I can take a look at is that these are pretty much interchangeable. It's just going back or forth if I want to. What we've learned all throughout here is learning that our sine of an angle gives us a very specific output for a coordinate. So everything that we've done, we've learned to memorize based off of angles. So up here, when I take the arc sine of some, this is some output value, it gives me some input value, it gives me some output value here. So if I take a look at here, now what we've memorized is that down here, okay, what I'm going to take a look at, is that sine of some angle gives me an output of 1/2. It gives me an output of root 2 over 2. So 45 degrees is root 2 over 2. 60 degrees is root 3 over 2. And 90 degrees is an output of 1. So I now get this problem, and I'm going to apply these properties. So I get the inverse sine of negative root 2 divided by 2 is equivalent to some x value. So actually what this is really asking you for here is this problem up here. Okay, that's how I'm going to relate it back to it, because it's basically saying when I did the inverse sine, it gave me what x was, so I'm trying to find the inverse sine of this y. So it's really this problem down here, just kind of like we're going to do it in reverse. So the way that I can apply this is that since this, okay, I can technically say, okay, well, to undo the inverse, I can say, okay, take the sine of it. So I'm doing the opposite. So taking the sine of its inverse operation then gives you it back. So then I would have this canceling out. Well, if I take the sine of one side, I got to take the sine of the other. So what now I'm left with is the sine of x is equivalent to negative root 2 over 2. Well, lo and behold, the nice thing about this, okay, is that I have the sine of x is equivalent to negative root 2 over 2. Well, I have this memorized. Well, I should have it memorized, that the sine of what angle gives me an output of root 2 over 2, and then I just have to make it the negative angle. So the sine of root 2 over 2 is 45 degrees. So again, coming back to my where my domain of this function is, that the answer to this value here, that x has to be, in this case, x would have to be, for this to be true, would be negative 45 degrees. Okay? And that puts me in quadrant 3. And again, why is it that I can't go and say, oh, that's 315 degrees? The reason is that this never gets higher than 90. So I have to use the negative value, which gives me this is x is equal to negative 45 degrees. So that's everything that we can do with the inverse of sine function.